Hello, this is homework 8, question 5, and it says, use any tool to demonstrate how to solve sine of 2x minus cosine x equals 0 on the interval 0 to 2 pi. So I'm going to use many tools to solve this, and the first thing that came to my mind was that sine of 2x. So let's look at the whiteboard. First of all, I recopied sine of 2x minus cosine x equals 0. And then, of course, I added cosine x to both sides. This entire time, I am intrigued by the idea of the sine of 2x because that reminds me of the double angle identities. And please don't be afraid of double angle identities or any trig identities. They're fun. So let's look at trig identities right here. This is trigidentities.net, and it tells us that the sine of 2 theta is equal to, so right here, we're looking at the double angle formula for sine, and this is going to crack the case wide open. All right, so remembering that we're going to use the double angle identity here, we also, I just want to put a heads up, a warning. Also be advised that in this case, the first case where I'm using the double angle identity, I have to tell you that the cosine of x cannot be 0. Hopefully you have a preview in your mind of what's going on here. The cosine of x cannot be 0. Let's look quickly at the unit circle. This is on mathmonks.com. The cosine cannot be 0, so the angle value cannot be up here, pi over 2, cannot be down here, 3 pi over 2. We can't have cosine equal to 0, so those two are out. X cannot be pi over 2, and x cannot be 3 pi over 2. All right, let's go back to our thinking about double angle identity. Here we go. The double angle identity for sine is this simple. The sine of 2x is equal to 2 times the sine of x times the cosine of x. Okay, we're going to do a little substitution. Back to our original issue, our original question. We know that the sine of 2x equals the cosine x, and we're going to substitute for the sine of 2x using the double angle identity. So, substituting in 2 times sine x times cosine x equals the cosine of x. I hope everybody knows what I'm going to do next. I'm going to divide both sides by the cosine of x. Ta-da! And once again, let's remember that in this case, case 1, we've already established that the cosine of x can't be 0, so it's okay to divide by cosine of x. We know that x can't be pi over 2. We know that x can't be 3 pi over 2. All right, one more step. Divide both sides by 2. And I'm looking for the case on our interval. Our interval is between 0 and 2 pi. Where on that interval is the sine of x equal to 1/2? Let's find out. Let's look at the unit circle again. All right, so up here is where the sine of x might be 1/2. I was tempted to look down here at the bottom part of the unit circle, but I had to remind myself that this is a positive 1/2. And it happens twice. It happens right here at pi over 6, and it happens over here at 5 pi over 6. Those are the two places where on our interval is presented beautifully right here. Those are the two places on our interval where the sine is positive 1/2. So those are 2 of our possible answers. All right, let's write them down. Okay, we have 2 answers. X, oops, I gotta do it again. X equals, and we just saw it, oops, I should use my finger. On the unit circle, x is either pi over 6 or x is 5 pi over 6. Those are 2 possible answers using the first case scenario when the cosine cannot equal 0. All right, let's go on ahead and find out what happens when the second case that we're going to think about. I'm going to pause my video. All right, I am back. Homework 8, question 5. You can see that we have the same question right here. We know the sine of 2x minus cosine of x equals 0 by adding cosine x to both sides. We know that the sine of 2x equals the cosine of x. I discussed case 1 a few moments ago, and I was very specific. I limited my domain to make sure that the cosine of x wasn't 0 because I was going to divide by the cosine of x. A couple things. First of all, it took me a long time to break through in my imagination to understand that, hang on a second, maybe I should consider what happens when the cosine of x might be 0. I have to think about it. And in fact, the cosine of x could be 0. Let's look again at the unit circle. The cosine of x is 0 when we are looking at an angle value of pi over 2 or 3 pi over 2. So let's consider that. The cosine of x could be 0. All right, let's think about it. X might be pi over 2. In which case, 2x is actually equal to 2 times pi over 2, which is pi. Let's think about the sine of pi. The sine of pi, over here on the left, is 0. So what we have in this case is that according to our original formula, the sine of 2x is equal to the cosine of 2x because they're both equal to 0. And this is one of our possible answers. Let me put a nice red box around it to show that it's a possible answer. Let's see, can I do this? There it is. There's one of our possible answers. Let's keep thinking. I know we looked at the unit circle, and we also found out that the cosine of, let's see, I think it was the cosine of 3 pi over 2 is equal to 0. This is part of our interval. Our interval goes between 0 and 2 pi. So 3 pi over 2 is on our interval. Let's think about what happens when x is 3 pi over 2. And when x is 3 pi over 2, what's 2x? 2x is 3 pi. Okay, not part of our interval, but x is part of our interval. X is 3 pi over 2. What is the sine of 3 pi over 2? I'm sorry, what is the sine of 3 pi? I misspoke. What is the sine of 3 pi? The sine of 3 pi equals 0. Okay, so we found another case. We found case 2, imagining that the cosine of x could be 0. We found two values where the cosine of x is 0. And in both cases, 2 times that angle value gave you a sine of 0. So in this case, what you're actually looking at is 0 equals 0. So we found 2 more instances, 2 more possible answers. One more double check. I like to double check. Looking at Desmos.com at the graphing calculator. Over here on the left, you'll notice that I typed in sine 2x minus cosine x. That's the original from homework 8, question 5. And I was going to say equals 0, but then this beautiful graph popped up. So I didn't. I left it as it is. And our interval, I probably should go back a little smaller. Our interval is between 0 and pi over, 0 and 2 pi. 0 and 2 pi is going to end right here. So we're kind of going between 0, the y-axis, and a little bit over here. And you can tell from typing into Desmos that this function crosses the x-axis 4 times. In fact, there are 4 values when the sine of 2x minus cosine x actually equals 0. Let's look at them. Right here, pi over 6. Well, that was part of our case 1. Right here, pi over 2. We discussed that with case 2. That's an example of 0 equals 0 because the cosine and the sine of 2x are both 0. Right here, 5 pi over 6. That was our case 1 when we limited our domain to divide by cosine of x. And right here, the fourth time it crosses, that's our case 2, where 0 equals 0, the cosine of x is equal to 0, and the sine of 2x is equal to 0. Okay, so from this graph, we confirm our 4 values of x on the interval between 0 and 2 pi when the sine of 2x minus the cosine of x equals 0. I hope that was fun and interesting. Thank you.